Hello friends, we are going to discuss about the Schrodinger's equation for the hydrogen atom in spherical polar coordinates. The hydrogen atom consists of an electron and nucleus which contains one proton. Nucleus is very heavy, about 1836 uh, times mass as compared to the electron. Hence, it can be assumed to be at rest. The electron moves around the nucleus under the influence of Coulomb force of attraction between it and the nucleus. The Coulomb potential energy of an electron revolving the nucleus in a particular orbit of radius r is V of r equal to Ze into minus E upon 4 pi epsilon naught r is equal to minus Zd square upon 4 pi epsilon naught r. So the atomic number for the hydrogen atom is 1, so Z equal to 1. So V of r equal to minus E square upon 4 pi epsilon naught r. Then the Schrodinger's equation for the wave function, that is Schrodinger's time dependent wave equation is del square psi plus 2m upon h cross square E minus V of psi equal to 0, or minus is h cross square upon 2m del square psi plus V of r psi equal to E of psi, or h cap psi equal to E of psi. Here h cap is the Hamiltonian operator whose value is minus h cross square upon 2m del square plus V of r, and capital E is the total energy having value E equal to p square upon 2m plus V of r, and del square is Laplacian operator. M is the mass of the electron. So in spherical polar coordinates, the Laplacian operator is del square equal to 1 upon r square dou by dou r, r square dou by dou r plus 1 upon r square sin theta dou by dou theta sin theta dou by dou theta plus 1 upon r square sin square theta into dou square by dou phi square. So this is the value of the Laplacian operator in the spherical polar coordinates. So therefore the equation 2 becomes as, by substituting this value in equation 2 means we have to put the value of Laplacian operator here, then the equation 2 becomes as 1 upon r square dou by dou r, r square dou by dou r plus 1 upon r square sin theta dou by dou theta sin theta dou by dou theta plus 1 upon r square sin square theta dou by dou phi square into the psi plus 2m upon h cross square E minus V of r of psi equal to 0. So substitute the value of equation 1, that is the value of V of r, which is equal to minus E square upon 4 pi epsilon naught r, and multiply this equation 4 by r square sin square theta. So equation becomes as sin square theta dou by dou r, r square dou by dou psi by dou r plus sin theta dou by dou theta into the sin theta dou by dou psi by dou theta plus dou square psi by dou phi square plus 2m r square sin square theta upon h cross square E plus E square upon 4 pi epsilon r of psi equal to 0. So this equation is nothing but the Schrodinger's equation for the hydrogen atom in spherical polar coordinates. The equation is sin square theta dou by dou r, r square dou psi by dou r plus 2 plus sin theta dou by dou theta sin theta dou psi by dou theta plus dou square psi by dou phi square plus 2m upon r square sin square theta upon h cross square E plus E square upon 4 pi epsilon r of psi equal to 0. So this equation 5 is the partial differential equation for the wave function psi of the electron in hydrogen atom, and which is called as Schrodinger's equation for the hydrogen atom. Okay, thank you.